Okay, today we're going to go through section 4.1, and it's called Crunching the Numbers. So for this particular chapter, this is statistics. So in statistics, this is probably the one of some topics in math that you can actually relate to in the real world. You can actually use it in the real world and understand it. So we just touch on it a little bit, and so we're going to go through some of the concepts of statistics that are kind of useful in your everyday life. So what is statistics? So statistics is a branch of math that involves collecting and organizing, summarizing and presenting data. So you're like, well, what's data? Data is information gathered from anyone or anything. So that's what data is. So you're pretty much collecting information, and then you're gonna somehow organize all that information and then present it to people. And you tell a story based on that information that you collect. So two important terms that come up is, well, how do you collect data and from where do you collect data? So there's two important terms that you have to know. So one of them, in a little bit, is going to involve a big area, and another one's going to be a small area. So collecting the data is going to require one to not be biased. You want to collect the data correctly. So I've seen people who collect data that are not done correctly. You'll see people who do polls, and only the people that have internet can do the poll. So it wouldn't be fair for the people that don't have internet to do the poll. But I mean, does everyone have internet? Well, not everyone has internet. Maybe the elderly do not know how to use the internet, or they don't have internet, so you don't get that population. I've seen people who at the mall, they're hired by companies to see how the people are spending or by their buying habits, and they'll send them to the mall to collect data. And so you may have seen them before. You go to the mall, I don't know, North Star Mall, and there's people with clipboards, and they come up to you and they ask you, "Hey, sir, hey, sir, ma'am, do you have time? I just want to ask you a few questions." And they'll say that they're just collecting data on figuring out what type of detergent that you use, right? And they tell you it's going to take a few minutes. And so before, they used to ask people, they didn't participate, they denied them, right? So now they're giving the people who participate an incentive. They'll give them gift cards, they'll give them movie tickets, movie passes, food, gift cards to food. So they're enticing people to participate in the studies. But of course, you'll have the people that are involved in collecting the data, they're not doing it correctly. They sometimes just ask a certain gender of their age to participate. So they're not really there to collect data, they're really there to find a mate, right? So you want to do it in a non-biased way, right? So what are the two main things about collecting data? Well, one term is the term population. So you can collect data from a sample or from a population. What's the difference? All right, so a sample, you collect data from a sample and it's based off of a random subset of a population. So you're like, well, what's a population? Well, think of a population like the United States, right? And you think about you want to go ahead and collect all the data from the entire population of the United States. That's a lot of people, millions of people that are in the United States. So, I mean, you can do it, but it's going to take you years to do it. Well, just like the census, right? That's a population. You're talking about an entire country. That's a lot of data. You may not want to go that route. you want to get a sample. A sample is just a subset of the population. So let's say that you ask our class to participate in the study. Well, that class is a subset of the entire population, and that's just a few people as opposed to millions. So a population is all possibilities in the world, a big group, whereas a sample is just a subset of population. So remember subset, it is just a part of the whole entire set. So those are the two things that you want to think about when you go out and you collect data. You want to do sample or population. Right? So we got other terms that we have to go through related to how you collect the data. There are different ways that you can collect the data. Right? So there's 4 of them. There's 4 ways to collect data correctly. So the first one is called random. What is random? That's where everyone gets an equal chance. It's a big group, but you're just going to pick people at random. Anyone gets picked at random. So that's what random is. You can get your people, all the people that you just ask people in general. Then you can put them on a spreadsheet and then assign them a random number, right? And so at the end of the study, you can at the end of assigning numbers, you just pick. Oh, I'm going to pick number 5. All the people with 5s can be in the study. That's random. So you choose without knowing who gets selected. That's just random. So that is random. The next one is called a systematic. Systematic is organized list, and every nth element is chosen. Right. So I know firsthand how that works. If you've ever been on a trip on a plane, you're going somewhere on a plane, and you get screened. Security purposes, you get screened. But just before you get on the plane, they'll do another screening. And just before you board the plane, they'll do another screening, and then they just count off 1, 2, 3, 4, 5. Every 5th person will get a random check just before you get in the plane. It's systematic. So that means every 5th person in line will get selected to be frisk, I guess. Right? They get searched again. So that nth is a set number. So they'll pick every 5th, or they'll pick every 7th. Then they'll count it off. 1, 2, 3, 4, 5, 6, 7. You're picked. 1, 2, 3, 4, 5, 6, 7. They're picked. That's what systematic is. It's an nth person or n item chosen to be selected. That's what systematic is. Stratified is another term. Stratified is a system where there are layers and you choose X number of elements from each layer. So think of like a cake, right? You have cake, you have layers. So each layer, you're going to pick a certain amount of people within that layer. We'll give you an example. Think of diabetes. Let's say that you're conducting a study with diabetes, right? So what are some aspects of diabetes that you are looking for, right? So what are some of the things that distinguish people to get diabetes? Well, first of all, there's different types. There's a type 1 and there's a type 2 of diabetes, right? And we also have to consider gender. Does gender play an important factor in diabetes? Probably, right? Probably. We also look at the age of the person. Maybe age has to deal with diabetes. Ethnicities, probably ethnicities. We also have weight. Weight could be considered a factor in determining whether someone has diabetes. Some say don't, but others say do. You never know. And we also look at genetics. Maybe genetics. Is it passed down from generation to generation? Probably. And also eating habits, right? You don't want to eat a lot of sugar in your diet because you could end up getting diabetes or salt, right? I've seen people, oh my goodness, I've seen people, I don't know if salt has anything to do with diabetes, but I know salt increases the likelihood of overweightness, right? And I've seen people just pour salt over the food. I'm like, wow, why? Why? Why do you need so much salt? But those are the eating habits. So these are your layers. These are your layers in determining whether diabetes is caused by these factors. These factors. So what this stratified process does is for each layer you pick. Let's pick the people that have type 1, type 2. We'll pick 7 of those. Gender, we'll pick 7 females. Age, we'll pick 7 people with age 50. We'll pick 7 Hispanics. We'll pick 7 that has a weight of a certain amount. I don't know. I weigh what, 189, 190. Genetics, we'll pick 7 from there. We'll pick 7 from the eating habits. So you're picking from each of those layers a certain amount of people. That's what stratified is. And the fourth one is called cluster. That's the fourth one. So we create mini groups. We are creating mini groups. So you're creating groups with certain layers, something like the stratified, but not entirely. So I'll tell you the difference between the two. So in this one, you choose only several groups, not all the groups. So like the stratified, you have to pick all the layers. Well, in this one in particular for the cluster, you're just picking several of the layers, not all of them, but several of them. But you have to choose everyone in that selected group. That's what cluster is. So stratified, you had layers and you pick a certain amount from each layer. Cluster, you have the layers, but you're only selecting a certain amount of layers, but you have to pick all of them from that group. That's the difference. So for example, if I ask people what their majors are, right? We have humanities, we have fine arts, we got people who are majored in cosmetology, human resources, we have art, liberal arts, we have criminal justice. So I have different groups, right? But I just picked these 3 to be in the study, but I have to pick all of them, all the people that are fine arts, all the people that are criminal justice, and all the people that are in cosmetology. That's what a cluster is. You're not picking some, you're picking all of them from those 3 groups that you select. That's what cluster is. So let's review. We had how many different types of ways can we collect data? There were 4 of them. We had random, systematic, stratified, and cluster. And don't forget the difference between sample and population. Sample is just a subset of the population, and the population is a whole big group. So knowing that will help you collect the data in an appropriate way. Okay, so now that we covered the terminology, now we get to look at the graphs of the data. So there's different ways of graphing. So I'm gonna in a little bit, I'll show you all how to graph using Excel, how to use pretty much Excel, and how to do it by hand. So I'll show you how to do both. So the first graph is called a frequency distribution table. A frequency distribution table shows how data are partitioned among several categories. We call them classes, by listing the categories along with the number, the frequency of data values in each of them. Okay, so that's what a frequency distribution table is. I'm going to show you an example of what a frequency distribution table will look like. So I'm going to get an example and bring it up. And so we'll give you an example where you have data that's just given, you're collected them raw, it's all given. And we'll create a frequency table. All right, so here's an example. All right, so we ask people, what is your blood type, right? And so here are the data. The people gave us the data. They gave us our blood types. Of course, I don't know mine. I think mine is O positive, I think. Not too sure. I have to ask my parents. There are the data. And so what you do is you create this table. This, my friends, is what a frequency distribution table looks like. So you have your categories. These are your labels. These are the descriptors of what type of blood type we're dealing with. The next column are called tally marks. Tally marks are what you're going to do is you're going to get each of these data values and you're going to put them in their correct category and you put little sticks. So you'll have a whole bunch of sticks depending on how many of these you have for each category. When you're done putting your little sticks there, you're going to count the number of sticks and that number goes in the third column. So for example, right, I need to list my categories. So my categories represents the labels that I'm using to represent the blood type. So I have a type A, I have a type B, I have a type O, not a type O, but a type O, and we have a type AB. So these are my labels for my blood type. So I'm going to go to my list, and for each of these data values, I'm going to put a little mark. For example, A belongs in type 1. I'm going to put a mark and cross it out. O goes in the third row, put a little line, cross it out. And I'm going to do it for all of them. B, A, B, A. So I did all these. The next column. B, O, B, A, O. Next column, 2 B's, or not 2 B, and 3 O's. 1, 2, 3. I got 2 ABs, 2 sticks, an A, I put 1 stick there, AB goes there, O goes there. Of course, when you do 5, I cross it out to make 5. You guys can continue with sticks. I got an O, a B, another O, right? A, and an AB. I hope I did it right. I hope there's 10. 1, 2, 3, 4, 5, 6. Nope, there's 9. There we go. B's. 3, 4, 5, 6, 7. Ah, here's the next one. No, there's 6. 6 B's. 1, 2, 3, 4, 5, 6. Oh, there's 7 here. 7. Type O, 1, 2, 3, 4, 5, 6, 7. That's supposed to be 9. 1, 2, 3, 4, 5, 6. All right, and then AB 1, 2, 3, 4. Yeah. So sometimes you have to go back and check to see if we got everything accounted for, right? So this one says I have 5 sticks. This one has 7. This one has 9. This one has 4. And if you want to know what the total is, how many people were surveyed, just add them up. This will tell you this total. So 1, 2, 3, 4, 5. There should be 25. Total is 25. 13 and 12, boom, is 25. 25 total. And then you can answer questions. You can ask, which blood type had the highest amount of people? I believe it was type O, which had the lowest. Amount. That would be type AB. So you can answer questions based off of your table. That right there is considered to be a frequency distribution table, because your categories is what makes this a frequency distribution table. And you got your tallies and you got your frequencies. So that's a frequency distribution table. Next one is called the grouped frequency distribution. All right, so this one, a group frequency distribution, right? A group frequency distribution is where the classes are intervals and the data are each placed in the correct interval to create the table. So the difference between the grouped and a regular frequency distribution table is that the frequency distribution table only has labels on the first column, whereas the group frequency distribution table has intervals. So let's suppose I asked my students, I asked them age of first alcoholic beverage consumed. All right, so think about how old were you when you first had your alcoholic beverage. All right, so what we do is we create our classes. Our classes will be considered the age, right? And the ages would probably run, I guess, starting from 17 through 20, 21 through 24, 25 through 28, 29 through 32. And hopefully I captured your age. If you went lower, I will call the authorities on your parents. No, I'm kidding. Okay. So that's what the classes are. So this is, it doesn't mean minus. It means the age from 17 through 20, the age from 21 through 24, age 25 to 28, age 26 to 32. And you go and you ask all the people in your study, and we get the tally marks. Right. And let's say that we have that amount. And you asked, and that's what they responded, right? So here's your tally marks, and then you add. So that would be your frequencies. So you would have 8, 12, 4, and 6. So just kind of refresh your memory. The frequency distribution table had, these were labels. A grouped one now has intervals, something between something. And that's what a grouped frequency distribution looks like. Now, again, you would add, to find out how many people were in the study, you would add that column. That would be 30 people, I believe. That's 20 and another 10, that's 30. So you have a total of 30 people surveyed. Okay, so now I'm gonna just go and look at the intervals. All right, our classes. Let's look at our intervals a little bit more closer. When you look at the intervals, the whole thing in general, the leftmost column of your intervals, these numbers, the ones on the left of each interval, these are called lower class limits. And the rightmost numbers of each of your interval are your upper class limits. So your lowers are 17, 21, 25, 29. And your uppers are 20, 24, 28, and 32. Those are your upper class limits from all of your 4 intervals. Now, if you look at how the intervals are created, there's a gap. If you look only at the lower class limits, there's a gap between 17 to 21, 21 to 24. I'm sorry, 17 to 21, 21 to 25, 25 to 39. There's a gap. There's an equal space between them. All classes are like that. There's an increment on how they go. It's supposed to be in sync. You don't want them different. You want them to be separated equally among each other. So from there to there, it's the same space as from there to there, which is the same space from there to there. They're all the same. That space, how do I figure out that space? Well, from 21 to 17, there is a 4 gap. From 21 to 25, there's a 4 gap. From 25 to 29, there's a 4 gap. That 4 gap that's occurring is what we call the class width. That is what the class width is, the increments. You can also even look at the green ones. Those are also going in the same equal increments. They're going in 4s. So the gaps from among the lower class limits are the same as the upper class limits, which means that your intervals are created perfect. They got to be the same. They cannot be different. They can't have 4, 3, 2 gaps. It's got to be the same all the way. It doesn't necessarily have to be 4. It can be 5. It can be 6. But it has to be consistent in order for it to be a good equal space. So that's what a frequency, group frequency distribution is. Okay. All right, we got one more graph. And that graph is going to be called a stem and leaf plot. Stem and leaf. You ever heard of stem and leaf? If you ever have to take, you change your major and you gotta take statistics. Usually the people that are going into the medical field or psychology or sociology, they have to take statistics. Okay, so what is a stem and leaf plot? So for a stem and leaf plot, for each data value, you break the number into 2 parts. You have the stem, which is the leftmost digit, and the leaf is going to represent the rightmost digit. That's what a stem and leaf plot is. I fill up that too. So we can do one with our birth dates. Right. So I asked my other class to provide me the birthdays, the day that they were born on, not the month or the year. Yeah, you don't want to give me the year, you make me depressed. But we want the day that you were born on. What day were you born on, right? So here is a list of the days that one of my class gave me for as an example, right? So they said someone was born on the 5th, on the 23rd, the 11th, the 13th, the 12th, 31st, the 15th, the 15th, 12th, 20th, the 8th, the 14th, the 17th, and the 19th. Day you were born. Students. I don't know why I wrote born so teeny weeny itty bitty, but born. Okay. All right. So to create the stem and leaf plot, you're going to create another little table like this, kind of like a T table when you're doing math. And you put your stem and you put your leaves. Right. And so what you do I'm gonna go backwards. I'm gonna start with my birthday, the 19th, right? What you do with the 19th is you get your 19 and you split it up into halves. You got your leftmost and you got your rightmost digit. So your leftmost will be your stem. So any number that has a 1, when you cut the number in half, a number 1 on the left, you start putting the leaf, the second digit, in back. And they don't have to be in any specific order. You can just start and just put the number. So because that has a stem of 1, I'm going to put a 9. So there's my 19. Next one. This is 17. It has a stem of 1, which means that I'm going to put the 7 in the same row with the 9 because it's, if you read it back, 19, 17. This one also has a 1 in front, so I'm going to stick it on that row with the 1 step. So that one reads 19, 17, 14. The tricky part is what happens when there's a single digit? Well, in this case, it only has 1 digit, which means if I split it up, it doesn't have a number on the left. So we assume that it is a 0. So I'm going to create a row with my stem 0, and any number that's single digit, I'm going to put the leaves in back of it. So that's where the 8 comes in. So I got 19, 17, 14, and 8. Next one is 20. I'm going to split it. Oh, that means I have a stem of 2. So I need to make a new row. And any number that has a 20, I'm going to stick the back digit here in the back. So there's your 20. 12 goes into, it has a stem 1. So I'm going to put the 2 right here. 15 has a 1. So I'm going to put the 5 there. Another 5. Ooh, 31. 31. That means I have to make another row for stems with 30s. And I'll put the 1 there for 31. Next one, 12. 12 goes there. 13 goes there. 11 goes there. They all have stem 1. So I'm starting to put the leaves back. That second digit, I'm going to put them in the back. 23, I'm going to put the 3 there. And finally, 5. 5 is a single digit, so that goes on my stem of a 5. So you can read the data back. 8, 5 single, 19, 17, 14, 12, 15, 15, 12, 31, 11. There should be a 20 and there should be a 23. And there's only 131. So that right there, my friends, is what a stem and leaf graph is. Now, why do we have to draw like this? Well, you can see how the data are graphed. You can't really see it this way, but if you turn it over, you can see the graph of the data. So it looks like a lot of people were born on a Teens Day. Weird. What were your parents thinking? So we have to look at the graphs of what this looks like. So there's 3 of them. There's 3 graphs that your data can look like. So one of them is called a bell shape curve. Right. So a bell-shaped curve is what it is. It's supposed to be symmetrical. What does that mean? A bell-shaped curve is a normal curve. That means in the center is the middle, and these two numbers are the same, and those two numbers are the same. So if you ever take a history class or government, and you take a test, and the instructor says, "Oh, the grade distributions for the test were bell-shaped," which means that you had the same amount of people making A's as the number of people who got F's. They're exactly the same. And they also had the same number of people who got B's that were the same as the same number of people who got D's. But a lot of people made C's on the test. Ooh, I remember that. When I took history at UTSA, our tests were always Scantron, and it always came out to be a bell shape. I always got a C on the test. Why do I keep getting C's? I just did not like history. So, and I think that was the same with everyone else. But you liberal arts majors probably love history. I just didn't. I couldn't picture it in my mind how things were because they always made us memorize stuff, which I don't like memorizing dates, but that's how it was. So that's a bell shaped curve. It has to be symmetrical. They got to be the same amount, and then the peak. That's a bell shape. You have two other ones. You have a skewed. Skewed means that the graph is lopsided. It's leaning to one side. This one's called skewed left. The tail is on the left side. So when it's like this, you have a few A's, a few B's, a few C's, a lot of D's, and a lot of F's. That's not good. That's skewed. You don't want that to happen in the class. You don't want to have a lot of D's and F's. That's not good. You rather have one of these, the skewed right, the tails on the right end. This is where you have a lot of A's, a lot of B's, C's, and then a few D's and a few F's. This is skewed right. This is skewed left. The tail is what makes it the skewed left to right. If you go back to our data with our birthdays, this graph would be skewed right. You have a lot of people born on the teens, right? And it tapers off. So this is a skewed right picture.